on him. So a little bit of background I would like to provide. Many of you know Ramesh well. He is our fearless leader. He's the one of the two founding co-chairs of the IEEE Blockchain Initiative. This is how the journey began. He will tell us more how it all started. And it is indeed my pleasure and honor to have a friend like Ramesh and invite him to do an opening keynote. And as much as the success of this, it lies on his shoulder as well, because he and I have had many conversations to where we are today. So therefore, it really gives me indeed my honor and pleasure to invite the founding co-chair of the IEEE Blockchain Initiative, Dr. Ramesh Ramadoss, to give the opening keynote. Ramesh, floor is yours.
Thank you. You should clarify co-founding. There were a few people who started it. So I see about 51 people on the line. I don't know if there's a way we could send a reminder. You mentioned 1,500 people signed up, right? Well, I will talk about blockchain, Web3, and Metaverse. Before that, is my audio okay? So you may hear some. Okay, yeah. You may hear some background noise that they're drilling something. I'm sorry about that, but I'll try to, be closer to the mic. So before I get into the topic, I will spend some time. And I'm assuming you guys see the screen, right? I'm sharing the deck. Okay, everything good.
Everything good.
So if you are new to this community, please go to blockchain.ieee.org, and you can join all of our platforms. We have, you're on LinkedIn, Twitter, Facebook, and there's also Collaboratech. You can also join our to click on this join the technical community, join all of it so you will get updates on our upcoming events. And we have these are global communities. You can be part of that. Also, you can be actively involved in local groups in different regions. They're actually in pilot right now, and we are hopefully will get them formalized next year. I don't know if you hear the drilling. This is what I was talking about. Sorry about the drilling. So this slide shows some of the activities that we've been carrying out under the Blockchain Initiative since 2018. Since January 2018, we've been organizing conferences and events, education modules. You can find several of them on the website. Podcasts, we have like a podcast one per month. By the way, how bad is the background noise?
No, it's fine. We don't hear anything.
Oh wow, surprising. So they're drilling like on the so that's good. So publications, we have several technical briefs that Gora is leading with a big team. So you can go read articles on our website. And standards, we have 11 standards, 58 working groups. So you can see a lot of these activities since the last, almost 4.5, close to 5 years. And we have a great team, steering committee. You can take a look. And one of the projects that we've been pursuing the last, I would say 3 years, and we, blockchain is blockchain for transactive energy. We have a team that's really, I think we should add more people, like Umit is also here. We have a position paper that anyone can download and understand about this project and how blockchain can be used for, transacting energy. For example, it could be a grid run by a small community. Let's say they have solar panels on their rooftop and they want to trade energy with neighbors, or even sell it back to the grid. So this can be done using blockchain in terms of like keeping track of the transactions, as well as tokenizing some of those transactions in terms of trading energy. So this position paper outlines some of those concepts. In fact, we are funding about 5 demonstration POCs. So please do sign up and download this paper. Now, I want to spend some time giving some background on some of the terms and use cases of blockchain in different areas, because today, today and as well as the next 2-3 days, we have, it's a 5-day event. So starting Monday through Friday, and it goes until Friday. So we have several speakers from some of the topics I'll talk about. So I'll highlight those. So please do join those events. So first, I want to talk about some of the terms, and starting with Bitcoin, and finally get into part 2 of the section. So let's see how much time we have. Okay, about 30 minutes. So everything started with this Bitcoin. Bitcoin is the first successful digital cash deployed on a peer-to-peer computer network. And there was a white paper published back in 2008, and the actual code was deployed in 2009. And it's basically a computer software that runs on a peer-to-peer computer network. And it's basically a recipe based on several key ingredients that are listed here, like public key cryptography, Merkle trees, and timestamping. As a matter of fact, Scott Stornada, who is considered to be the grandfather of blockchain or co-inventor of blockchain, is speaking right after my talk, in 30 minutes. So how he came up with this timestamping idea. In fact, they built the first blockchain back at when he was at Bell Labs, and he had a startup. So he will talk about that in 1990. So you can see, these concepts, including like proof of work algorithms, secure hash algorithm, all of these have been around for decades. We're talking about since 1976, almost, 45 years, something, right? So Bitcoin basically was a recipe that kind of put together all of these things, and that's how it was created. And it really set the stage for a new field called blockchain. And that's, blockchain, you can actually understand this evolution in terms of 3 stages. First stage is what we call as blockchain 1.0, and where, Bitcoin and many other cryptocurrencies were launched based on Bitcoin, and they're called, we call them blockchain 1.0. And then blockchain 2.0 is kind of a turning point where, some of the chains like Ethereum and Corda and Hyperledger were launched, where you can actually deploy smart contracts, do sophisticated, contracts for transfer of assets and agreements and so on. And 3.0 is where, several architectures were launched to address the scalability issues and interoperability issues and so on. Now, so I know we have, as I said, 5 days of content, and I wanted to kind of define some of the terms. So because there's a lot of terms that are being used in this space, and it can get overwhelming and sometimes could be misleading. So I start my talk defining some of these terms before I get into some of the details. So the first term you need to know is DLT. DLT stands for distributed ledger technology. Basically, it's a database, distributed database that can be shared among multiple participants, and it can be updated through a consensus mechanism. So a simple way to understand it is like if I create a Google Sheet, Google Doc, and share it with people on this call, 58 people, and then we have an agreement that how we update it. Like, let's say half of the people on the call must agree to make a change to it. That's the consensus mechanism. So that's a simple way of trying to understand this, but when you try to simplify things, it may be misleading sometimes. But now let's talk about the second 2 terms, like 2 more terms, blockchain and DAG. So blockchain and DAGs are basically subtypes of DLT. So DLT is a generic term. That's why we have this big box. And then blockchain and DAGs are, data structures or subtypes of DLT. And next slide, we have more details. So now we have what is blockchain and what is a DAG, right? So blockchain is basically a chain of blocks where, each block consists of a batch of transactions. Remember, all of these architectures are designed for handling transactions. So each block here consists of a batch of transactions, And you can see, this chain of blocks, and the blocks are linked to each other through a, hashing function. So this is the longest chain we call the blockchain. So that's the definition here at the top. And there's also DAG. DAG is basically an interconnected data structure. Like it's not linear like blockchain. You can see it's a linear data structure, whereas DAG is, you can call it like a graph data structure. They're interconnected. That's the nature of these two. And there are some examples here. You can see blockchain, Bitcoin, Ethereum. These are blockchains, and DAG, like we have there are Hashgraph, IOTA, and so on. So three terms, right? We talked about DLT, we talked about blockchain, and we talked about DAG. Now, if you were to look at the architecture, basically we have a distributed computer network. This is the foundation for everything we're talking about. It's distributed computer network is basically a collection of autonomous computers that appears to its users as a single coherent computer. And on top of that, you can kind of like put that aside, because that's the foundation for everything like blockchain, DLT, DAG. Everything is running on a distributed computer network. In fact, even the Google Drive, Google Docs, everything we talked about earlier, they all run on a distributed computer network anyway. So now the two concepts that you need to pay attention to, one is the ledger. So ledger is basically where the data is stored, and where the transactions are stored in the network. And then we have the consensus protocol. That defines the rules and parameters by which the transactions are basically approved and added to the network. So based on these two concepts, ledger and protocol, you can come up with three different types of blockchain DLT architectures. Like, ledger could be public or private. The validators could be open or closed group. So we have three types: public permissionless type. So the ledger is public. Anyone can join the network and anyone can approve the transactions. And public permissioned is ledger is public, but only a closed group can validate the transactions. Private is basically a ledger which is private. Only a closed group can view and also approve transactions. Let's really make it simple to understand. So going back to the Google Doc example, so I can create a Google Doc and share it with everybody, right? Anybody in the world can view it. Also, anybody can actually go and make changes, edit that. So that's the first type, public permissionless type. And public permission type is where the same Google Doc, if I just, I can make it visible to the whole world, but then only the people in this call, like 68 people, or minus me, 67, can edit that. That would be a public ledger, but permission type. Only a small group can actually edit. Now, private type is, same Google Doc, if I just make it visible to only 68 people on the call, and only the people, 68 people, it could be even less, 10 people in this call can edit that. So that's a private type, right? So these three architecture types are, if you understand these three, they'll help you understand the blockchain ecosystem. Like, for example, the Bitcoin, Ethereum, Cardano, they're all public chains, And enterprise and governments are using private blockchains like Hyperledger. We have like a whole track on Hyperledger, as a matter of fact. So now, in terms of consensus protocols, there's a whole list. There's a table here of different consensus protocols being used, and then to summarize, basically, it's these the protocol and the ledger is the key. And as we go through some of the use cases, you have to kind of like keep that in the back of your mind. Now, let's look at some fun, interesting stuff that's happening in the space. Again, the first section was primarily to just give you some clarity on the terms and different types of blockchains, like, DLT, DAG, and different types of like public permissionless, private, and all that. But as we go through some of these, I will highlight what they're using in different use cases. So let's look at the startups, right? So anyway, by the way, this is an article that just came out this month in IEEE Potentials. I, have a detailed like 6-page article that talks about some of the things that I'll talk about today. Now, I will go through some of them quickly. And by the way, Gora, seems like I got a text from Scott that he's having trouble with the logging into Hua. Maybe you could
I'll take care of it. Yeah.
call him. And so this graph shows the evolution of cryptocurrencies, digital asset in the starting with Bitcoin. Bitcoin set the stage for several alternative coins, and then stable coins were launched to address the volatility of Bitcoins. And then Ethereum, like we talked about, blockchain 2.0 enabled programmability of smart contracts that really enabled served as a test bed where a lot of these experiments were being carried out and is still ongoing, like things like DAO, decentralized autonomous organization, DeFi, decentralized finance, NFTs, games, Metaverse, all those things. And I'll talk about a couple of those things today. And then we will also get into what enterprises are doing with blockchain and governments are doing with blockchain and so on. But this is primarily about what's happening in the startup space. The public blockchains we talked about could be public permissionless or public permission type. This is all like stuff you can see in terms of transactions and all that. Now, why, you can see here there's so much interest in terms of funding in the space. All these topics we talked about here, like DeFi and DAO and games, Metaverse, and there's a lot of money being invested. Of course, the last few months, it's less than before, but still, $1 billion. Like last month, October, 1.5 billion invested in a lot of these projects like blockchain and we call it Web3, but we will talk about that later. Now, why is it such a big deal? Like why there's so much interest in investments and all these new concepts? So stepping back, like what is blockchain bringing to the table here is blockchain basically introduced a new paradigm in the history of computing where the economic models are baked into the protocol at the protocol level. So you can see this, this Venn diagram shows intersection of three things, right? One is you have the computing technology and you have the economic model, and then there's a community that's interacting with these models, right? The protocol is at the middle. So, but in terms of the architecture, protocol is, we talked about the consensus protocol is, top of the ledger, and then it's a wallet application, and many applications are built on top of this. So the digital assets, like programmable assets like coins and fungible tokens, non-fungible tokens, they're all actually programmed at the protocol level. And this really creates a new economic model, like in terms of incentivizing the users, the developers, the programmers, as well as investors. So this is creating like community around like a protocol, like could be like an Ethereum community, and different projects have their own ecosystem built around this new economic model. In fact, there are universities focusing on just the crypto economics. So now moving on to the next slide, this slide shows several applications that are built on top of blockchain. So today I'll talk about a couple of these things like games and Metaverse. So in fact, NFTs as well, because it's hard to talk about games and Metaverse without NFTs. So NFT is type of a digital asset. It's you can see here unique, non-interchangeable asset programmed on blockchain. In the case, for example, could be Ethereum or other Ronin chains where, you can see this, it could be anything. It could be a digital file such as photos, audio clip or a song, or it could be a video clips. But some of the popular NFT projects are shown, and there's still a lot of debate about, what is the value, long-term value and things like that. And Now, if you look at some of the top projects, and you can see that volume of trading here, like $4.2 billion traded in a number of traders. You can see sales and all that. So it's in the order of billions. So it's just something significant. Whether this is going to be there 10 years from now, that depends on the actual utility. And some folks claim that it's just simply like a piece of art that it's a rare item that they want to hold on to, and the price would go up as it becomes a rare item or scarcity. Now, games is another area that's been under development on blockchain, where in the case of blockchain-based games, what happens is when you play a game, you get tokens, reward points, and those reward points have some market value. You can go sell it. And so in traditional games, like you earn points, but those points don't have any value outside that game. For example, like just to make it simple, like American Airlines. So if you're flying a lot with American Airlines, they give you miles, you get miles, but you can use those miles only in the American Airlines, right? If you want to buy a ticket, you could buy a ticket using the American Airlines, but you can't use American Airlines miles to buy a ticket from United. It doesn't work. So there's this, but in terms of here, blockchain creates a virtual economy where you can earn points, reward points in one game. You can take it out, sell it, and go to another game. So this creates a virtual economy that connects different games. So you can see number of users, for example, on a top game, it's like 1.8 million users in the last month, but still, it's still small compared to if you compare it to a traditional game like Roblox. I think they have like 200 million users. So still has a long way to go, but folks in this space are very hopeful of the future. Now, next thing you've been hearing quite a bit about the last, I would say, couple of years now. I mean, it's been around for some time, but it is, especially last year, it's become very popular. Metaverse, since Facebook changed its name, and now there's a lot of reports and talks, and in fact, even conferences focusing on Metaverse. Now, if you want to know what it is, it's basically it combines physical world and virtual world, like could be a headset, VR headset or AR headset, and combines the virtual digital assets, like we talked about NFTs and tokens. So that's what this circle, green bar circle represents digital assets that comes from the blockchain space. And some of the top Metaverse projects on blockchain are shown here. When I say on blockchain, they have some kind of cryptocurrencies or NFTs as part of it. And it's, for example, NFTs are used to represent a plot of land, or it could be an avatar, it could be skins, weapons, those kind of things. And folks do, sell these things, buy and sell these NFTs for, to make money out of it. And in fact, not only for selling, folks are also renting it out. For example, people with capital, they buy some of these NFTs like weapons, and they rent it out to players who are good at playing, and then they collect rent. So it's creating a whole different new dynamics and economy in this space where this blockchain is involved. But in fact, blockchain companies or blockchain communities not the only one looking at building metaverses. There's a whole bunch of companies looking at getting into metaverse, like so Facebook and Microsoft, and you can see a whole list of companies here. Now, let me move on to this next topic. I think we have about maybe 12 minutes. This topic of Web3 versus Web 3.0 versus decentralized internet. So these terms are currently under a lot of debate and discussion among different communities. This is actually pretty recent. What you see here, like on the left side, you see a CN CNN video. It's pretty recent on why they talk about how blockchain enables Web3 and decentralized internet. It's like a 30-minute video. You can watch it, and get an idea. But that's all like talking about how blockchain is the key for Web3 and decentralized internet. On the other hand, these are two different opposite views here. On the other hand, there was a talk recently by Tim Berners-Lee, who's one of the, he invented World Wide Web. And his point was blockchain is not a viable solution for building a decentralized internet. And of course, he has a project. I'll talk about it shortly. So there's a lot of discussions and debates of what is Web3 and Web 3.0 and decentralized internet. And if I were to show you an example, here's an example of what it means from the view of blockchain community, where they talk about like owning the data or even digital assets like tokens and NFTs we talked about. Instead of a company owning these things, now you're able to own it. That's kind of the philosophy where how things have evolved from Web 1 to Web 2 to Web 3. Now you can own data and assets, and those assets would be recorded on blockchain. And as I mentioned earlier, there is this virtual economy of trading. You can trade these things on crypto exchanges or even decentralized exchanges. There's a market value for these tokens, and so on. Now, this is a little bit busy slide that shows like Ethereum community thinking about creating a decentralized internet, like based on decentralized storage and computing and messaging system. Everything like is based on decentralized components, but this is still an ideal vision, has not been implemented yet. And this is again from the blockchain folks thinking about how blockchain can enable decentralized internet. Now let's look at another example of this is Tim Berners-Lee's project, where he's they have a startup Solid, where they're talking about creating a decentralized internet where the data ownership and creating a social applications based on decentralized architecture. Again, the common theme seems to be the ownership of data and also I guess privacy, but of course the term decentralized or decentralization itself is a very nebulous term that you don't have time to get into those today. But so I just wanted to give you a sense of how fast this space is moving, and there's debates and discussions on what it means, and that gives you a sense of how early we are in the space. Now let's look at some of the use cases that the enterprises and governments are looking at, based on blockchain. And now let's get into the first section, enterprise. So this is an old graph, but it shows you, like some of the big companies are doing pilot or using blockchain for different areas like capital markets, supply chain, and it could be energy and transportation and so on. It turns out that 80 of the top 100 companies, large companies, are looking at blockchain. Now, there have been alliances and consortia formed by companies to either build the infrastructure like Hyperledger. As I mentioned earlier, we have a track on Hyperledger. And also there have been alliances formed around specific use cases, like companies or the transportation industry. They formed this BIDA alliance, and then automakers, like all the top automakers in the, they actually created this MOBI alliance. It stands for Mobility Open Blockchain Innovation. So you can see there's a lot of activity. It turns out that there's a lot more. You can see there's over 478 consortia in the space on different topics. You can see like automotive, energy, and so on. So it's pretty active in terms of, there's a lot of interest on blockchain from the enterprise world. Again, these are some of the blockchain as a service platforms built by cloud service companies in the US, in India, China. Basically, they added blockchain as a service or BaaS to their existing cloud platforms. And well, just to get a sense of what kind of use cases, like you can see supply chain, land registry, There's also invoice management. These are some of the use cases. You can see a lot more if you go to this website, Hyperledger website, and look at the case studies. Okay, now let's look at what governments are doing with this technology. Okay, here is a list I created today. You can see European Union has multiple initiatives and projects. Like you can see the whole list, and they've invested, I think, close to about almost 700 million euros on blockchain. And of course, United States, NSF has a program on DLT, and recently, the White House announced a position for blockchain director. I think they're looking for somebody to start next year. So there's a lot of activities and interest going on, and of course, China, Dubai, as well as India. Some of these countries are not comfortable with crypto, but they're still using the blockchain, private blockchains, for some of the applications, like, for example, trading securities, for example. Now, this is just diving more into some details on what European Union is doing. They're building this infrastructure called EBSI, European Blockchain Services Infrastructure. This is for cross-border services among the EU members, where, for example, they want to issue identity. It's easier for EU members to move around and not having to prove, the identity, and also for sharing data, also for diplomas management. For example, a student who graduated from Germany and they moved to Poland, it takes some time for them to get the degrees, and a few weeks. But if you put all the degrees on this common infrastructure, like all universities in the European Union, they put their data on, share this degrees, everything on blockchain, then it could be instant verification. So that's, they're looking at 4 main use cases, still in a very active ongoing project. Now let's briefly look at CBDCs. So central banks across the world are looking at issuing digital currencies on private blockchains. And you can see from the color coding, there's several under research, several under proof of concept, the purple ones, and there are also a couple of live ones like Bahamas and Jamaica. They're live. Rest of them are, in fact, I think even in China, there's the digital yuan. It's live in a small scale, and like in the Beijing city around like that. So you get an idea. Like it's pretty interesting to see how things went from Bitcoin about from 2000 launched in January 2009 all the way to now. Like governments looking at issuing, or central banks looking at issuing digital currencies on blockchain. Again, to clarify, these are issued on private blockchains. Now I think I'll stop here. That will give us like 5 minutes. That's my LinkedIn, and also you could check out our website, blockchain.ieee.org. So I think we have 5 minutes. By the way, Gora, did you resolve the issue with?
Yes, he's online.
Okay, cool. So any questions or comments? Let me see if there are any questions.
And folks, you can raise your hand or type in your questions on the chat, please.
Okay, there's a question from Don Patterson. How does a CBDC provide value over digital national currencies we have? I think, there's a whole lot of reports being published by, BIS, Bank of International Settlements, and so on. And so the idea of CBDC is where, everything could be electronic. There's no need to print a paper. So when you completely move to CBDC, there's not going to be any more paper printing, and it's you'll get paid electronically, and also the taxes are going to be collected before we get paid. That's my guess. But so there are a lot of things. In fact, things are, as I said earlier, like China Digital Yuan project is already live. They actually did a test last year with McDonald's and Subway and all of that, and like around Beijing area where everything was on smartphone. So well, I'll stop here, and I think we have some couple of talks on this topic as well. Maybe we'll put that on here.
Yes. Thank you very much, Ramesh. Let's give a big hand to Ramesh for, as usual, a phenomenal introduction to what the world of blockchain. Thanks, Ramesh. Absolutely, that was fantastic.